Okay, this is an example where we need to solve for x, and we have a square root or radical in our equation. We have a couple of students online. No microphone tonight, so can you type your steps? What would be the first step? Okay, we have in the chat room saying that we should isolate the radical. Exactly. So we need to isolate the radical by subtracting 7 from both sides of the equation. And then once we isolate the radical, what would be the next step, anyone? Go ahead and type your answer. And the next step is saying that we have to square them. Yeah, we isolate the radical and square both sides. Notice that we are not squaring each term. We square both sides. Okay, so on the left-hand side, I would get 2x plus 1. We eliminate the radical. On the right-hand side, this would be like x minus 7 times x minus 7, or best would be to use the formula. The formula here is a minus b squared would be a squared, and then we have b squared. What would be the middle term? Those of you logged in the chat room, can you tell me what's the middle term here? Just type your answer for me. Okay, the answer says AB. No, not that right. You put 2AB. Okay, so it would be 2AB, but now depending if this is minus or plus. If this is minus, in this case it's plus, so this would be plus 2AB. But if this were minus, then that would be minus 2AB. So remember that. But the last term always is positive. Always positive. The first term and last term always positive. So in this case, we have first term square would be x squared, and then last term square would be 7 squared, 49, and the middle term would be minus 2 times 7 would be 14x. Again, remember the last term always is positive. If you forget this, which you shouldn't, but you can go x minus 7 times x minus 7 and multiply term by term. And you get the same answer, of course, if you did that. You get x times x is x squared. You get minus 7x minus 7x. That would be plus 7 squared, which is 49. You see the middle term always would be minus 2ab, which is minus 14x. So at this point, we eliminated the radical. Now I can move everything to one side of the equation and simply solve for x. So if I subtract 2x from both sides of the equation, I can move it to the right. If I subtract a 1 from both sides of the equation, and then everything would be equal to 0. So now we have an equation x squared. You can combine like terms. Minus 16x plus 48 equal to 0. Now to solve this, I need to factor this. Now if this is not factorable, then we can use quadratic formula, but in this case we can easily factor that. This would be x and x. We're looking for two numbers. When we multiply them together, we get 48, and then we add them up, we get minus 16. So 4 and 12, and then if both are minus, we get minus 16. So we get two solutions here. we get x minus 4 equal to 0, so x is equal to 4, or x minus 12 is equal to 0, x is equal to 12, and then we need to check the answer, make sure which one of these are a true solution, and it looks like 12 would work. If I substitute for each x12 here, 12 times 2 would be 24 plus 1 would be 25. Square root of 25 would be 5. 5 plus 7 is equal to 12. However, 4 is not going to work, because that gives me 2 times 4 is 8. 8 plus 1 would be 9. Square root of 9 would be 3. Like 3 plus 7 would be 10, and that's not equal to 4. So only 12 is the answer. X is equal to 12. And then I see in the chat room somebody put x plus 12 times x plus 4. So you have to be very careful when you factor this. Your signs are correct, otherwise you get the wrong answer. So you want, when you multiply this 4 and 12, you want to get plus here, so both has to be minus. And when we add them up, we want to get minus 16, so both has to be, again, negative to add up to negative 16. So once again, when you have an equation involving radicals, the first step is to isolate the radical, square both sides, combine like terms, factor, make sure you check the final answer if they're correct. If I had a radical x instead of x here, then I cannot really isolate the radical, because if when I move the 7 to the other side, then this radical won't be isolated. But you at least separate the 7 here, and you have to square both sides once, and then reduce, and then square it again. You have to do it twice. If you cannot isolate the radical, you at least separate the radicals, and you square one time, and then separate them and square again. Look for the sessions I have for the example where you cannot isolate the radical, then you have to do this process twice. But for this one, we can easily isolate the radical, so we can square one time and we eliminate the radical. I see somebody typing a question here. For those of you logged in here online, it would be great if you can set up your microphone so you can talk. It would be a lot easier.